Hey, welcome to The Explainer. Today, we've got a real tech detective story for you. We're talking a determined coder, a super powerful AI, and a bug that was just maddeningly hard to find.
And really, it all boils down to this one question. Can you actually build something you totally don't understand just by using an AI as your guide? What happens when you hand over the reins completely? Well, we're about to find out.
All right, so here's the mission. Get two little computers, a Raspberry Pi and an STM32 board, to talk to each other. The language they're going to speak, it's called a CAN bus. Now that's the kind of system you'd find in a car. The catch is, our coder knew basically zero about this stuff, so they decided to let an AI take the lead, using this method called agent-driven development.
So what is agent-driven development, or ADD? Think of it like this. The human is the hands, doing all the physical stuff, and the AI is the brain. In this story, our AI brain is named Claude. Claude is supposed to provide all the code, all the instructions, all the debugging help, basically your digital co-pilot for the entire project.
So Claude, the AI, spits out this wiring plan with all the confidence in the world. And our coders, they follow it perfectly. Connect this wire to that wire. CAN high to CAN high, CAN low to CAN low. And this is the important part. Power the Raspberry Pi's little module with 3.3 volts. Okay? Lock that detail away in your brain. Seems pretty straightforward, doesn't it?
Okay, so everything's wired up. Time for the moment of truth. Or at least a first check. Does the hardware even work? The AI suggests running a simple diagnostic. It's called a loopback test on both devices.
And you know what? The result was a total success. I mean, everything passed with flying colors. For a second there, it looked like this whole agent-driven development thing was going to be a walk in the park. Imagine that, a super complex system built with no prior knowledge, and it works on the first go. Or did it?
Yeah, this quote from the person who actually ran the experiment says it all. So far, so bad. That feeling of an easy win, it was about to completely unravel. Turns out the AI had overlooked something really, really important.
And here's the big gotcha. A loopback test? It's basically a device talking to itself. It's an internal check. So yeah, it confirmed the chips were okay, but it never ever sent a signal across the actual wires connecting the two boards. And the AI, it just didn't mention that part. So the most important piece of the puzzle, the actual communication link, was a complete unknown.
So, riding high on this false victory, it's time for the real test. The plan was simple. The Raspberry Pi sends a signal over the bus, and a little LED on the other board is supposed to blink every time it gets a message. That's it. Simple.
But the reality was absolutely nothing. The LED just sat there, staring back, unblinking, for an entire afternoon, just nothing. A complete, total failure. The project went from, hey, this is easy, to completely dead in the water, just like that.
So, what do you do when your AI Genius Guide totally fails? You go back to the AI, right? The coder asked Claude for help, and Claude's response was basically, well, my code is perfect, so it has to be a hardware problem.
And this is where things get really weird. The AI just went completely off the rails. It got this one idea stuck in its head. You could almost call it an AI hallucination. It became absolutely convinced that there was a tiny little solder bridge on a USB port, something that wasn't even there, and it just would not let it go. It's a fascinating look at a flaw in these systems. Once they latch onto an idea, man, they can get stuck.
So this whole bug hunt turned into a 2-day ordeal. As you can see here, day one was a total write-off, just chasing this imaginary USB problem that the AI invented. But on day two, something shifted. The AI actually started to find some real clues.
And then, a breakthrough. The AI actually found something real. It spotted a jumper on the board that was shorting a pin to ground. They removed it, and hey, the voltage readings look good now. A huge step, but the LED still wasn't blinking. The main mystery was still unsolved.
Okay, so having run out of all its other wild theories, Claude did something very human. It finally decided to read the instructions. It asked for the name of the board's manufacturer and started digging through the official documentation online. Now remember what I told you to lock away in your brain? Way back at the start, Claude confidently said that the Pi's CAN module needed 3.3 volts. The entire setup, the whole thing, was built on that one single instruction.
And there it is, the smoking gun.
After finally checking the specs, Claude found the truth. The board had its own internal voltage converter. It didn't need 3.3 volts, it needed 5 volts. The AI's very first instruction was the one that broke everything.
So, the coder switches the power supply over to a 5-volt pin, runs the code one last time, and blinking. We have a blinking light. After 2 full days of frustration, of chasing ghosts in the machine, the case of the unblinking LED was finally closed.
So, what's the final verdict here? What did we learn from this whole agent-driven development adventure? I mean, it was a total roller coaster, right? The AI caused the failure, but it also drove the discovery. Let's unpack what that really means. Here's the really wild takeaway. The AI was kind of both the villain and the hero of this story. It created the main problem in the first place, and then it sent the human on a wild goose chase after a phantom bug. But it also managed to find both of the real hardware issues all by itself. And maybe the most amazing part of all this is that, in the process of fixing the bug that the AI itself created, the human learned an incredible amount about this complex system, way faster than they would have on their own.
And all of this leaves us with a really big question for the future, doesn't it? As we start relying more and more on these AI tools to help us build and code and create, if your AI copilot gives you the wrong map and you end up driving off a cliff, who's really responsible? Who's at the wheel? It's something to think about. Thanks for tuning in.